We created a desktop app in Python using Kivy and Matplotlib. The first task was simply plotting orbital period in years against distance from the Sun in AU to the power of 1.5 for each planet and plotting the line of best fit. You can use the gradient and y-intercept 2 decimal places to show that they are equal. For the second task, you can use the semi-major axis and eccentricity of each planet to calculate and plot its orbital path. The 4 inner planets have been separated from the 5 outer planets, which includes Pluto. The third task is almost the same as the second task, however you need to turn it into an animation. For this, we simply plot the planet on a single point on its orbit and create a function which regularly updates the position of the planet on its orbit, making it seem as if it's moving. The fourth task is the same as the third task, but it's in 3D. For this, you need to use the inclination angle and calculate the z-coordinate of each planet at a given time.
The fifth task uses Simpson's integration method to plot orbital angle against time for Pluto. We fill up a list with the necessary coefficients, which is a required number of 1s, 2s and 4s, then use this along with the other calculations to calculate the graph shown. To create the spiral graphs in the sixth task, we use a code from the third task, where we select only 2 planets, and every time their positions update, we draw a line between them. If you run this for long enough, it will create a nice pattern. You can only choose 2 planets from the inner 4 or the outer 5, because otherwise it won't work due to the large difference in orbital periods. Finally, we again reuse the code from the third and fourth tasks for the seventh task, but the animate function must be changed. In order to put the chosen planet at the center of the solar system, you must set its coordinates to always be at 0, 0 if in 2D or 0, 0, 0 if in 3D, as both dimensions are options. You must also change the points of all the other planets by doing their original position minus the position of where the center planet would be if the Sun was at the center at a given time. This creates an animation with the chosen planet at the center.